Hello and welcome back to the Building HVAC Science podcast, where it's our goal to help create better, more knowledgeable HVAC and building performance technicians by helping these two professions better understand each other, the work they do, with the ultimate goal of making customers happy in the homes they live in and the buildings they work in. You probably are a regular listener, I'm guessing. If not, my background is working in the HVACR and building performance markets for over 30 years. And I've noticed a need for scientifically rooted information on how to do a technically correct job. That's part of why I do this podcast. The other part of it is just having had so much wonderful experience with people, with colleagues in the trade. I want to share that. I want to help enrich your thinking, perhaps enrich your life and career. That's really a heady topic right there, huh? Speaking of heady topics, Eric Kaiser and I had the pleasure of interviewing the man, the myth, the legend, and our friend, Jim Bergmann, in this episode. As Jim's business has grown, there are a lot of new updates and activities and events happening and coming up soon with measureQuick, Jim's business, his main project right now. You can go to the measureQuick site for more details, especially the resources page, links in the show note. Some significant quotes and thoughts from the interview. Here's one. Changing the culture in a company is hard to do. It must start from the top. They don't make products like they used to. Or is it you that hasn't kept up? Manufacturers have refined their designs. Installation instructions have serious details that they assume all techs will follow. And here's a newsflash. After this was recorded, the measureQuick 2.5 public beta is now available. And one of the significant upgrades is guided workflows. Joe Medash has done a great video on this. There's other videos out there you'll find on the resources page. But if you go to measureQuick's YouTube channel, and again, link in the show notes, you can get a video on this measureQuick 2.5 public beta. There's a bunch of other notes, links in the show notes that will help you understand or dive a little bit deeper into some of the rich topics that Eric, Jim, and I discussed. Okay. Enough of this background. Let's get into the discussion where we focus on commissioning an HVAC system is hard. Doing it with measureQuick is easier.
I'm sure we can find something good in 40 minutes of content.
Okay.
Oh, hey, everybody. Welcome back to the Building HVAC Science podcast. I am your co-host, Eric Kaiser, and next to me, virtually, co-host Bill Spohn.
Hello.
And today's special guest, Mr. Jim Bergmann.
Hello, Eric.
And Waffles? Is Waffles on board today?
I don't know where he went. He's sleeping somewhere.
Oh, okay.
That's a good question. He probably has food in the cafeteria, which means that's where he's usually at.
Yeah.
Oh, smart Waffles.
Mm-hmm.
All right. Today, we are talking about all kinds of stuff. And I think we're going to start this off with how they really don't make products like they used to. Is that right?
I think it's a starting place because I think that's what a lot of perception is. I don't know that it's reality, but it's definitely the perception that we're seeing in the industry this day when it comes to the longevity of equipment.
We've heard this statement for a lot of years. I've heard that probably as long as I've been in the trade. They just don't make things like they used to. And that goes for a lot of products today in the world. They don't make them like they used to. And I think it's a very accurate statement. But when I hear that statement made, a lot of people are saying that the quality is gone in things. And I don't know if that's necessarily true. And especially in HVAC, I think there are a lot of quality products still put on the market. In my experience, maybe we haven't kept up with how to work with those products. Maybe they are not obviously the same as they used to be, but maybe we need to change the way we work with them or the way we treat them a little bit to make them last as long as things did in years gone by.
I would care to argue the point and say that the products are high quality. The installations are not. And we're really eroding as an industry what we perceive as a quality installation. I think we've sometimes forgotten more than we remember, and we're in a huge hurry. I was going to drag this out early here. This is August 7th, 2023, HVAC News. Preliminary DOE study, ongoing current Building America study, reveals that only 23% of newly installed residential HVAC systems are perfectly charged. 23%. And you go back to the 70s, we had air-equipped fittings, and they were charged from the factory. And I bet you it was bordering 100% that were properly charged. And now we've taken a factory procedure, made it a field procedure, and look where we're at.
So that's interesting because I wonder, obviously properly charged can be very subjective because are they measuring this charge to the airflow?
It was within 5%. So that was the other thing. Only 40% of the systems had, I believe it's around 40% had correct airflow. And for them, correct airflow is over 350 CFM per ton. So we're not talking correct for climate zone. We're just talking that it wasn't obscenely low airflow. And then those systems, they looked at the subcooling or the superheat target. And the subcooling target really, it won't vary that much with airflow, maybe a degree or so, but most of them were within 5% of the correct charge, but that also yielded a lot of faults.
That's a lot of problem systems out there because now we're talking about, if I heard you right, 60% of systems that did not have proper airflow or had airflow that was below 350 CFM per ton.
Yeah, so the researchers determined only 23% of systems tested were charged with the perfect amount of refrigerant, and approximately 60% of systems were within plus or minus 5% of charge. The good news is the majority of systems within a close range, but the bad news is that 40% deviated more than 10%. And then approximately 13% of systems showed the perfect amount of airflow, 350 CFM per ton, while approximately 45% were underperforming. They just put a stake in the sand for airflow and didn't look at, obviously, sensible latent split, because we all know in Arizona, 350 CFM per ton is low airflow, and in Ohio, it's still low airflow. But I think in this case, they're just putting a stake in the sand and saying it's just not obscenely off the charts low airflow. So that even makes it worse.
I'm going to add another twist from a little different direction. When the manufacturers design their products today, they're using all kinds of advanced tools. And Jim, you've actually visited with some manufacturers, and not everything's perfect with the manufacturers either, but assume they're using advanced tools. They're really trying to do it right, but they're trying to do it as economically as possible. Not cheap, but as economically as possible. And I'm going to make the statement that the installation instructions are serious. In order to get the performance that was designed, you got to get those right. That's part of this quality installation concept.
It's a big part. Obviously, the manufacturers, one of the things, I can't remember where I even was reading it just recently, but I was reading something along that whole guidelines of that things that manufacturers could do were to provide better, more clear instructions. But the issue is that we don't have people that are actually reading even the instructions when they're vague. I was just working with a contractor last year, and in fact, you won't even mind me saying who it is, Chad Simpson from Simpson Salute. And they spent over $100,000, I believe, and he's got 100 employees. So they spent hours and hours and hours reading a manual for a furnace installation. He said it was the first time that they had ever read an installation manual. And after it was done, he decided that the reason that they went through this activity was because he was telling me, yeah, I went to do a commission with measureQuick and it was really hard. And then he said, well, you needed to read the manual because I'm not asking him to do a single thing that's not in the manual. Then he goes, after we did it all by hand, we figured out that measureQuick is really easy. Commissioning a furnace is really hard. And we had never done one right in our entire career. And the reason that they were so adamant about this is they had 100 systems that they had to go back on at the first cold snap because of a manifold pressure setting that the guys didn't catch during the installation. And then there was additional things our guys caught along the way, like that how the traps had to be installed and what traps could be common with other traps, what traps could not, issues with flue pipes, installations, and just little tiny nuances that the guys weren't paying close attention to that now they've corrected on their previous installations, correcting on their current installations. But this is common across the industry, the problems we're seeing. And this is obviously part of the reason we're having this discussion is like there's such a huge opportunity for reduction in unneeded warranty claims. It impacts everybody from the consumer who's got to make the call that their unit's broken to the contractor that's going to come out with a no-cost warranty truck roll to the distributor that's now got to replace this part that may or may not be bad, to the manufacturer's got to supply the part. Somebody's got to make it. Then everybody's got paperwork they got to do. It's a paperwork nightmare to track this part all the way through. And then somebody's got to reorder that part. We're changing parts that probably don't need change because we don't understand them. We're changing parts that don't need change because improper installation maybe compromised them. We're not fixing it at the root cause analysis of why that part failed, because it probably wasn't a defect from the manufacturer. It's highly likely it was something else. And we're also experiencing a part shortage. And it's like, there's so many little problems we could fix that we are not addressing, let alone we could also chat about things like warranties, these 10-year warranties. They put those things out there with the assumption that if it's installed correctly, it'll last 10 years. That's a really good assumption if it's installed correctly, but we can see from this ongoing Building America study that they definitely aren't.
So data you were talking about, something we shared with you yesterday, was from Warranty Week. The total warranty claims for 2022 for the HVAC industry was 891 million. And the average expense rate for HVAC industry was 1.2% in 2022. And that's a 5% increase from the previous year.
So our skill levels are actually declining, is what it's showing you.
Eroding.
Yeah, because we're losing a lot of our most skilled labor.
It could show that, but it could also just show that people aren't connecting the dots. And that's, I think, mainly what we're here to do today, is connect a lot of dots. Going back to that statement where Eric started in, was they don't make products like they used to. They do. They make them better than they used to. But we aren't assigning the importance to the installation like we should be, and the importance of following the instructions and using tools to get us there.
I do think, though, in all fairness, like you look at a 1960s cast iron heat exchanger, you could lose the fan and run it for months, let it cycle on the limit, and it wouldn't damage itself. But that also came at a cost. That furnace took a week to install. You had to take the heat exchanger down piece by piece. You had to pour a concrete slab to put the thing on. It had to be all assembled with nuts and bolts. Today, we take a furnace down the steps. One or two guys can take it down and install it in a day. So with that technology that we've picked up, these lighter, and also these furnaces, obviously, they come up to steady state operation faster because they're low mass. The standby losses are less. There's a lot of cool stuff with the new technology, but it does not put up to improper installation. It does not put up to cycling on the limit. If we did the same thing with a modern furnace and ran it through the same cycles without the blower for a month, it would be destroyed. So equipment is better from an efficiency standpoint and a longevity standpoint, because we do put safeties in to keep that from happening. But it still is a huge challenge for us to get these installations, especially on the airflow side, correct.
You published a really good article. It's a measureQuick blog post about the train wreck coming back in February. That was related to heat pumps. Really good article. You even quoted me in it and Nate Adams. But I also want to remind listeners, if they haven't listened to last week's episode about the heat pump summit that's coming up, that's something that hasn't happened yet, but it's coming up in November. So go back and listen to that. But do you want to talk a little bit about the thinking that made you write that?
The cool thing with a summit is you're on top of the mountain, which means the only place you have to go is down from there. What really got me with that whole concept was that we're talking about the whole idea of electrification. And electrification is definitely something that is doable. Let's just get that out of the way to begin with. This is something that we could achieve. But what I was saying is we can't achieve it with the current skill gap that we have and the current practices that we're doing when it comes to just general installation practices. I mean, my gosh, if we can't get charge rate on an air conditioner, heat pumps are way more critically charged than air conditioning is, especially when you're talking about in the heating mode. So we're never going to get the efficiency and capacity and longevity out of these heat pumps if we can't even get it right in air conditioning systems. And we have really great tools to do this, but what we're not following is a process. We're very much, everybody has their own process that they follow, and it's not a defined process like ACA quality installation or things like that. But then when we show them the actual process that they need to follow, they're like overwhelmed because it's such a complex process. Like we're updating to measureQuick 2.5. We're going to launch sometime this month. And we took the whole measureQuick application and focused around this process of quality installation and just of installation in general. But it walks the technician through step by step by step. And it's taken us probably an easy year of talking about it and an easy 6 months of programming it and continually changing it as we're going through thinking about, oh, well, what if this happens or that happens or what order we want to do things in? That's all we've done is focus on this process. And it's a daunting thing when you've got to do this. People don't appreciate what it's actually going to take to get a quality installation done. I think that whole article is really about, we have all the tools, we have the right software, we have all the right equipment, we have the manual J, manual D. I mean, everything's out there we need. It's just a matter of people have to embrace the process. And it's not necessarily an easy process, but if you follow it, you'll be successful.
And you have to believe you'll be successful, or you need examples of other people who are successful. And I think that's part of why you give away so much of your time talking about this. And we really hope this message reaches more contractors, more technicians. They can be more successful.
It's not about the technology as much as it is about the business case and how you're going to deploy this in your business. Because the technology is nifty and we have it and it works. You can do all this kind of stuff. But as a business, you really have to understand what it's costing you to miss opportunities and also what improper installations are costing you over time. What's the cost of to your marketing budget when you have to work with a ticked off customer? What's the cost to the truck roll? What's the cost of the warranty paperwork you're doing? There's so many costs that we could be avoiding just by doing it right the first time. Yet we just tend to talk about those as, well, that's just part of doing business, instead of putting up a mantra, you know what, this is not part of how we do business anymore, because we have tools that'll make sure that that doesn't happen. But it's a mindset. I mean, I'm going out to see a contractor tomorrow in the Dayton area, and he said, we're one of the largest contractors in Dayton, and our mantra is, we're going to get it fixed for you today. We don't want to take that call. And they run out, they'll change the capacitor, and he goes, I know I'm losing money, I know I'm missing opportunities, but I can't figure out a way to slow down enough that I can get to all these customers that we want to service and provide them with like a measureQuick quality installation. It just takes, in his mind, it takes too much time. But I honestly don't know that he realizes how much that it's actually costing him to operate that way.
There's also emotional wear and tear on everybody. Nobody likes going back and redoing work. Was it you that said recently that don't create your own service calls?
Yeah, there's nothing worse than servicing what you just installed. It's very expensive to do that. And contractors that are embracing installation, like Gettel's a really good example because they QA, QC everything with measureQuick. They have a second set of eyes to make sure the charge is right, the airflow is right. They're fully leveraging the software to do all that. So that enables their technicians to be out searching for opportunities for either repair or replacement and finding new customers instead of out fixing what the installation department just put in. And a lot of companies, that's a big problem where their service department is dedicated to their install staff. And a lot of times the service department even eats the installation errors and they're not billing that back to the installation department where they actually started at. This is one of the reasons service departments sometimes don't look profitable in companies when they're actually your largest revenue generating potential of the whole company. But it's just that mindset, I think, going back to you got to look at what are the costs to your business, who are we billing those costs to, and how are we going to fix this?
If you look at warranty expenses, that really comes off, especially when you're talking about labor, that in most companies comes straight out of the profits. And a lot of companies in HVAC run thin on profits anyhow. So it makes sense to me to try to do it right the first time. I do have some questions for you, Jim, though, on the numbers you were talking about in the news article there in the DOE survey. Say a unit is 10% off on charge. What does that do to the performance of that unit? And I'm going to ask you this because I know you've done quite a bit of testing with different charge levels and things like that to develop measureQuick. How much does that affect the performance normally that you've seen?
It's not a linear relationship. It's actually an exponential. So as you start losing a portion of the charge, it impacts the performance pretty drastically. I'd actually have to go back. So there's a NIST study, Vance Payne and his group down at NIST just ran. It was sensitivity of faults on heat pumps, I think is what it was, and multiple faults. And they actually ran through all that because the faults are actually additive. So like low airflow and low charge compound to other problems. And then it also depends on the type of metering device that you have. There's like, what you're asking is not really an easy answer, but it's actually how we built measureQuick's vital scoring was we're looking at what the correct charge is and how far they're away from the target. And then we used a modeling of those equations so that we could do that system scoring. And the biggest things that impact performance overall, and it also depends on your motor type, like your blower motor type. It's like a PSC motor has a much higher impact on blower performance than an ECM motor, but an ECM uses more power to overcome the poor duct design. A fixed orifice system has a higher sensitivity on charge than a TXV does. But it just comes down to, at the end of the day, any charge but the correct charge and any airflow but the correct airflow is going to compromise performance. They've shown this over and over again, and the energy losses are anywhere from 4 or 5% to 30% in that study, depending on the number of faults, the severity of the faults. But that doesn't include anything like client comfort. It doesn't include anything about equipment longevity, number of potential warranty calls because of this. I mean, it's so common today for people to get a new system installed and it doesn't perform as well as their old system worked. I mean, we saw that with all these new high efficiency variable frequency heat pumps hitting the market where people are saying they don't dehumidify because they weren't operating them with the correct controls and they didn't really understand how the equipment operated. And I just think there's like this problem is so much bigger than just the energy losses when you start looking at the comfort, the warranty. I mean, in a consumer, the only thing that they can do is turn down their thermostat further if they're not comfortable. And in like Texas, a 2-degree change in temperature is a 20% increase in energy usage. So again, it's pretty massive when we're looking at these problems. And to try and quantify them on a single variable, I think is tough. I just don't know if there's an easy way to quantify your question because it's without doing a little bit of digging into exactly, like we'd almost have to run some numbers and just see. But it's anywhere from, like I said, 4 to 30% typical energy loss. And then right now we're just talking about charge and airflow. We're not even talking about duct leakage and ductwork outside the envelope. It's loss upon loss upon loss.
Yeah, and this really goes back to the fact that split system air conditioners or split system heat pumps, everything, most of what we put in the U.S., the final assembly is all done in the field. The installation technicians are the final assembly point in the system. There's major components assembled in factories and shipped to that job, but everything needs to be QC'd in the field to a really high degree of accuracy. Otherwise, it's probably not going to work as it was designed or as it was engineered. And the other piece too is not only we're talking about energy loss, but we're also talking about capacity losses. We have lower capacity. And I think that's one reason why equipment tends to get oversized, which of course costs more to operate, is because it's never set up right. Then the capacity can be squishy on it a little bit more.
Well, it's a little bit more than squishy because there's in the same study, they said a 2006 to 2013 study by NCI said that only 57 to 63% of the BTUs promised by the manufacturers were delivered to the occupied space. That number is also sort of unsettling when you think about half your energy is not ending up in your space. I think that's primarily with ductwork outside the envelope. And this is where it's going to be a huge issue when we start putting in heat pumps because it's going to be the same thing. And heat pumps don't have the surplus capacity to lose. And we can't oversize them that big because we just don't have the duct systems that can carry that much airflow. I mean, my gosh, if you're in a northern climate, the way this thing works, everybody would be putting in a 5-ton heat pump when they really need a 2.5 to 3-ton because they're going to assume that 50 to 60% of the energy is going to go outside of the envelope. We've got to step in, and this is what we've been trying to do for the last, 7-8 years now with measureQuick, is to help and build. Heck, this goes all the way back. I don't remember when I was teaching at Cuyahoga Valley. You and I talked about this early on. Was we had all the right measurement tools, but we didn't have people that knew how to use them. We talked about writing a book just on measurement, and then Corbett Lunsford came in and wrote that initial book on measurement. And then I think Hap Haven was way ahead of his time when he came out with a Contractor's Guide to Home Performance. I just dug that out the other day, and it's like we had some people out there that were like ringing the alarm bells, but I don't know that the market was ready to hear them at that time. They were a little bit ahead of themselves. But now, if you go back and you look at what they were talking about, that there's a lot of that. It's nothing new. It rings true, as true today as it did back then. It's just right now with this electrification movement, it really, really matters because it's not even about cheap energy. It's about equipment longevity and the stuff actually performing. That's the big thing. If you can't keep your house warm, who's going to want it?
Yeah, and it goes back to delivered comfort and everything else. Now, something you mentioned in there was the statement that the equipment needs to have correct airflow. And I hear this statement a lot out here. We have to have correct airflow. And some people say it's 450. Some people say it's 400 CFM per ton. Some people say it's 350 CFM per ton. Let's dig in a little bit about where the technicians need to find correct airflow and how we know as a technician going out to set up a piece of equipment, where does the quote unquote correct airflow number come from?
It used to be like years ago, this was a lot easier question because we paired a 2.5 ton condenser with a 2.5 ton coil. It's like the equipment matched, and engineers and designers figured out, okay, to get the optimum amount of heat transfer, the coil had to be designed a certain way with a certain number of passes at a certain temperature difference. And because all the manufacturers are bound by physics, all of them worked out the same. It used to be we could say we need 450 in Arizona, we need 350 in Florida, and we need 400 in Ohio. It was like you could look at regions and say, in general, these are the airflows that you should be looking for. But today, the manufacturers are pairing up that same 2.5 ton condenser with maybe a 3 or 4 ton evaporator. And the design temperature differences of the evaporator are crazy. And you'll see some of the manufacturers with airflows listed in the HR directory as low as like 300 CFM per ton. You'll even see sensible latent splits sometimes at 0.8, 0.9, or as low as 0.50 I've seen. And so the only way a technician today would really know how to do that is you would have to go through and do a manual J, first of all, and figure out what your latent and your sensible load is. And then you'd have to go back and find a piece of equipment using manual S that's going to be able to meet those criteria. And then you'd have to go to that extended performance data and normalize that piece of equipment and select the airflow that you need that's going to meet the sensible and latent capacities at the design conditions, and then set the airflow accordingly. Because it could be 300's the number, it could be 400's the number, it could be 450's the number. It really depends on how the manufacturer designed it. And like some of these systems, they're gaming the SEER rating. And this is why SEER 2 came into effect, because they were using these really, really low airflows to start wringing water out of that coil and get the sensible, get a ton of latent capacity instead of latent. And by grading the system off total capacity instead of off the sensible, which satisfies the stat. So these equipment would look really high efficiency, when in reality, it would never be set up that way. So you would, even some of the manufacturers have efficiency mode and a comfort mode switch in their equipment, where they're like, hey, we know nobody's going to use this efficiency mode, at least not after the first month. So switch to comfort. It'll drop the airflow down. It'll start to dehumidify like their old system did. Then they'll be happy. So now it's gotten so crazy that for what we did for, I don't know, the last 30 years, think about, Eric, you and I were both service technicians. How many dehumidifiers did you install in your entire career? I put in one. When you were service tech,
I'll say a couple when I was in the field.
I serviced 1 or 2, but what I'm saying is today we're talking about, in fact, next week's the DOE's final ruling on humidifiers. We're talking about you're going to need to add a humidifier to your current system to control the humidity separate from the sensible load, because these new units are not dehumidifying like the old ones did. They're more based upon sensible cooling. And so now, if you really look at the efficiency of a dehumidifier, it pulls out maybe 1/10 of the amount of moisture that you can pull out with your air conditioning system, just a tiny little fraction of it. And they are not efficient for anything but do great at dehumidifying, but then they add sensible load back to your house again. And if you ever look, it costs me as much. I have a Bosch unit in my lab, and I have a general air dehumidifier. It costs as much to run the general air dehumidifier as it does to run the Bosch unit. So I've got this 20 SEER unit, and then I'm compromising it with the dehumidification, because now I got to run the dehumidification all the time, which is adding sensible load and removing some latent, where if What we ended up doing was reconfiguring the Bosch so we can control more of the latent load. What I'm saying, if I just kept that Bosch in its highest efficiency mode, or it didn't dehumidify with a 45-degree coil, every bit of energy savings that I just achieved, I just lost to now adding this dehumidifier back in to control the latent load separately.
And we've added a second piece of equipment or another piece of equipment and extra controls and everything else.
Oh, yeah, something else to maintain. And we know that dehumidifier, you're talking, let's say $1,000 to $2,000 for that kind of a product. Yet it's only going to last you for 15 years, if tops, on that type of product. And now I've got another filter I've got to maintain in that product. And it's just another one of the challenges we're going across. But again, going back to what your question, what's the correct airflow? You actually have to do it through manual S is how we're going to get it, because otherwise we're just not going to know.
We got to come through manual J, and we really need a leakage test, a house leakage number, a shell leakage number in manual J to accurately calculate that latent load as well.
In reality, too, I mean, let's be honest, a lot of times what we're doing is we're going back and seeing how the home's handling the humidity load. And if we got to slow the fan down a speed, we slow the fan down a speed. Even manual JDNS, they're all educated guesses, but we don't know if they're going to have a marijuana farm growing in the basement or a giant fish tank in there or whatever. We don't know how the occupant's going to live in that house. We make assumptions about that. And they run on the bathroom exhaust fans when they're taking a shower. Do they put a hot tub in their basement? God knows what they're doing down there. But we actually do have to commission the equipment initially. Then we go back and fine tune it for the application sometimes later on.
So realistically, what we should be doing is at least putting some sort of a monitoring system in there to watch the house for, say, the first year and get it through a couple of seasons and see how the equipment's running and find small tweaks to it. Is that what you're thinking?
I think so. Yeah, this is where products like Haven come in, where we can monitor the temperature, the relative humidity, the temperature swings, the dew point temperature of the air, the particulates in the air, and make sure, honestly, if you don't measure, you don't know. I think that was Rudy Leatherman that said that, or Jim Davis, one of the two. It's been stole by everybody around the industry forever. But at the end of the day, there's a lot of truth to that. Is what are we doing post-installation to assure the equipment's operating correctly? With measureQuick, we can commission it. But once I leave there, I don't know, do they have a particulate problem? Do they have a temperature problem? Do they have a humidity problem? Because unless we have a tool to monitor those like Haven's doing, you don't really have an opportunity. Again, there's no reason you can't go back to say, Mrs. Jones, we've been monitoring your system for the last year. We can see your humidity levels are constantly running up in the mid 60%. We could get that down a little bit lower if we did this. Maybe it's adjusting your fan speed. Maybe it's adding a dehumidifier, whatever the solution is that you want to offer. But there's absolutely nothing wrong with doing an initial commissioning than having data to go back and actually optimize.
You mentioned Haven is one of the tools that give you that continuous observation, but there's also Smart AC, which would do the same thing. And I know you work closely with both of these companies and you see them as being more tools in the arsenal to better manage business for costs and customer satisfaction.
The cool thing is with Haven is the ability to actually monitor and control. So I think that's a really key element. And there are two different products from the standpoint of one is an indoor air quality product. The other one is really a maintenance product. Smart AC is definitely going to do better diagnostics, look at your runtime, tell you what's wrong with the system. I think they both have a place. I have them both on my own system at home. I have them both on my systems at the office here because the data provides me a lot of insights into how the systems are working. But at the end of the day, I mean, back, it's maybe even 30 years ago now, my dad and I were contractors. We worked with a company called Bucket Supply out of the Cleveland area. And they were ICP, International Comfort Products at the time, who's now, I think, owned by Carrier Corporation. And it was right when all these hot surface igniters and flame rod systems were coming out. And the industry just had a huge glut of circuit boards that were going bad. And my dad and I were putting these furnaces in all the time. And we had zero issues, and we didn't know there was any issues because we never had any issues. We didn't know other contractors were having challenges with these appliances. And Stan, who is the general manager at Buckeye's, like, hey, the guys from ICP, they want to meet with you guys. And we're like, what about? And they're like, well, you don't have any warranty issues, and we want to figure out why not. How come you guys are putting these in and you're not having warranty failures? And it ended up, Dad was a new appliance and it had electronics on there. Dad read through the instructions on there and he's like, well, now it requires a ground wire. And he goes, these units, a lot of the companies were not rerunning a new ground. So they were using like the casing on the Romex. So they had a crappy ground. A lot of times those things broke internally, really thin. So Dad's just like, I'm just going to run a new wire on all these furnaces. And it was a decision in passing more than like a conscious, we need to protect those electronics thing. It was just like, let's just go ahead and do it. So we did it. And that ground was so critical to flame rectification and not breaking down the triacs in those boards. And we inadvertently avoided a ton of warranty issues. And we were small contractors, and that would have been a nightmare for us to have to go out to all these people's homes. And what's interesting is I think these manufacturers, when they're designing the stuff, they don't sit back at the factory and go, what do you think would happen if we installed it without a ground? Or I always wondered, is somebody at Daikin or Carrier or Trane going, what do you think would happen if we don't evacuate the equipment and we just cut the charge in and let it go? And it's because they know something's going to happen that's not good. But we were talking to a property management company, 1,000 units that were never evacuated properly. And they ran a year like that. They're all running at 50% or less of their rated capacity and efficiency. Again, like our industry is rampant with these problems, and they could honestly be fixed with some software and some training. I think Chad Simpson said it best. He's like, it takes me 5 years to teach a technician. It takes me 8 weeks to teach them a process. And measureQuick's a process he teaches. And by teaching that process, they eliminate a lot of those warranty issues. They eliminate a lot of their headaches. But it's something he's actively had to do this. It's not, he didn't toss his technicians tools and say, hey, go at it. He actively trained them on that so they could achieve what he's achieved, which is a huge reduction in warranties and things like that. And it's helped them in a lot of other areas of their business. And their manufacturer, he told me the other day, his manufacturer even, their distributor noticed that they have substantially fewer warranties than any of the guys around them. That says it all right there.
That's a very competitive advantage.
Yeah, it is. And if we think about that, by reducing warranty claims across the board, that's also going to help control equipment prices, which is a big pain point for a lot of contractors today. And I hear a lot of contractors complaining about it because that trickles all the way back to the manufacturer, because the manufacturers, of course, have to support a lot of the parts warranty claims that come back, and even some of the labor in some cases.
And we got to realize, too, is a lot of these systems are one and done. If you don't install it correctly the first time, there's no way to undo the damage that you've done to it, especially when it comes to oil contamination like on mini split systems. So it's so critical we're doing proper flaring and we're doing proper evacuation and we're doing decay testing to make sure we're doing proper dehydration. Because if we're not taking those extra steps to assure that product is going to have a good long life, it's going to end up in a scrap pile at 5 to 7 years or even sooner. And Bill, you went through that headache. And what was sad is you offered the contractor all the tools and everything he needed to do it. But again, it comes down to that contractor wasn't willing to put forth the effort.
Yeah, desire, motivation.
That's what's so hard. That's why measureQuick's been such a long play for us, is changing culture in a company is the hardest thing to do. And it's got to start at the top down. I think that's like, bring up some examples. Ken Goodrich is like, they ghettoize everything. When they put measureQuick out, they had to tell a couple of employees, hey, if you're not going to embrace this, you're no longer a ghetto employee because this is the direction we're headed. Same thing with Rayo Cook out in California. They had that same sort of a mantra, but I think some contractors today are like, I can't tell my employees that. I can't afford to lose an employee. And it's, I always wonder if you increased your efficiencies and you got rid of all those callbacks, you got rid of all the headaches that they're causing, would you really need them at all to begin with? Are they making their own busy work because they're just not good at what they do?
So we talked about a lot today. There's a lot of connections or things that are going to come out of this. We actually have Josh Tico coming up on episode 36 of the podcast, talking about smart AC. Talked to Kevin Hart back on episode 111. Last week, we talked with Brent Davidson for the Heat Pump Summit. Got measureQuick 2.0, 2.5 you've alluded to coming out within the next few weeks. Got some webinars scheduled that people can look at the measureQuick events page. Just go to measureQuick.com, touch on events, and shortly you'll start to see some webinars populate there. So I'll also include in the show notes the NIST study link. I found that from Vance Payne And I'll include a link to your electrification open letter and even a link to that electrification video that we did at the symposium earlier this year. But there's a lot going on, a lot of resources out there. I like your statement, Jim. Changing culture in a company is hard to do, but it's got to start from the top.
100%. Well, hey, thanks a lot for having me on the podcast, Bill. Eric, it was fun. Sorry if I monologue too much. That's my MO. So
we expect nothing less.
We just sit back and let you roll now.
Right. All right. Good deal.
Thanks, everybody, for listening.
Thank you for listening to this episode of the Building HVAC Science Podcast, where Eric Kaiser and I spoke with Jim Bergmann on the topic of commissioning an HVAC system is hard, doing it with measureQuick is easier. I also host the Res Talk podcast, where you can learn more about the rapidly expanding world of home energy ratings and peripheral topics. After listening, if you like what you heard today and you're not subscribed to the podcast, please consider doing so by clicking the subscribe button in your favorite podcast app. If you're interested in communicating, reaching out to me, you can do so through marketing@truetechtools.com email address. And of course, the topics we cover here, especially with Jim, require technical training for proper interpretation or safe execution. So if you're trained pro, you can go right ahead with what you've heard. If you are not, please consult with and hire a trained pro. The Building HVAC Science Podcast is a production of TrueTech Tools Limited. In full disclosure, I'm a co-owner of TrueTech. The opinions voiced are those of my guests or myself, depending on who is speaking, of course. And if you're in the market for some tools or test instruments mentioned in our podcast, take a look at TrueTechTools.com, TrueTechTools.com. See what we carry? You can use the offer code HVACBS for a nice discount. I want to thank you for listening to this podcast and following us wherever you can, Building HVAC Science Facebook page, or follow me on LinkedIn or TrueTech Tools on LinkedIn. And we hope you gathered something from this episode to change your way of thinking, at least at a minimum, get you asking some questions. And we hope we have achieved the goal of helping to create a better, more knowledgeable HVAC and building performance technicians in a small way by this episode. Thank you so much for listening, and we hope you come back again to the Building HVAC Science Podcast. Take care.